First one says if tangent is -8 and sine is positive, find sine and cosine. It is not -8 over 1. If they give you the fraction, we can probably assume that a lot easier. But the ratio between sine and cosine is -8. So that doesn't tell me what sine and cosine is. So we can't just use, well, tangent sine over cosine. Can't do that. So let's use the properties. We have sine squared theta plus cosine squared theta is equal to 1. And that's just the equation of a circle. X squared plus y squared equals 1. It's a unit circle because the radius is 1. I want tangent in this, so we divide by cosine squared. So we have tangent squared theta plus 1 is equal to, that becomes secant squared. Tangent and secant go together. Cotangent and cosecant squareds go together. Now if I square tangent, that's 64 plus 1 is equal to secant squared theta. So secant squared is equal to 65. That means secant is equal to plus or minus square root of 65, just by square rooting. And then we can go beyond that and say, well, now we know that cosine of theta is equal to plus or minus 1 over square root of 65, which is plus or minus square root of 65 over 65. Now we have to determine whether we want cosine to be positive or we want cosine to be negative. If sine is positive and tangent's negative, that means sine over cosine needs to be negative. Well, if sine is the positive one, cosine better be the negative one. So by looking at a combination of what sine is and what tangent is, I've just discovered that I want cosine to be negative. So the answer is negative square root of 65 over 65. Now, to get sine, I'm going to use the fact that if you square this right here, I don't care if it's plus or minus, you're going to get 1 over 65. So cosine squared plus sine squared should be equal to 1. I don't care if it's plus or minus when you square it. That negative would go to positive. Sine squared is now equal to 65 minus 1, right? Common denominator, that's 64. 64 over 65. So sine now is equal to, not plus or minus because they tell me that sine's positive. It's positive 8 over square root of 65, which is 8 square root of 65 over 65. So I found the sine and I found the cosine. Sine's positive, cosine has to be negative. Any questions? Awesome. Simplify. Cosecant times secant minus cotangent theta. Or yeah, they're all secant thetas and cosecant thetas. We got to make it more simple. One of the techniques that we have to use is make everything sines and cosines. So cosecant is 1 over sine. Secant is 1 over cosine. Then we have minus cosine over sine. That's cotangent. We really have two fractions subtracted. And to subtract two fractions, we need common denominator. So the denominator over here is sine cosine. So how about we give this the same denominator by multiplying the top and bottom by cosine. We would have 1 minus cosine squared theta over sine theta cosine theta. And I see something in this that you have to be able to recognize. You have to be able to recognize that 1 minus cosine squared is sine squared. And you're like, well, where do you get that? If you have this first Pythagorean identity, sine squared plus cosine squared equals 1, you can minus over the cosine squared. That's 1 minus cosine squared theta. So just by manipulating them just slightly, you can change what 1 minus cosine squared is. That's sine squared over sine theta cosine theta. And you have to be able to recognize that. Now, I can recognize it easily, but so what if I can? I've been doing this for 1,000 years. You have to practice it enough, though, so that when you get to 1 minus cosine squared, you're like, oh, yeah, I know what that is. That's sine squared. one of these cancel, and you're left with sine over cosine. But even more simple is tangent. Sine over cosine is tangent, and that's what we want as the result. One of the techniques we have is turn everything into sines and cosines, and not only that, but we used common denominator there also. Now this one down below, it already is in all sines and cosines. Can't choose that, but these are two fractions subtracted. So let's use common denominator. We need to multiply this one by cosine x, and we need to multiply on top and bottom, and we need to multiply this one by 1 minus sine x, which is the other denominator. And of course, we're multiplying top and bottom by that. On the left side, you get sine of x times cosine squared x. And then we get 1 minus sine squared x. These two right here, those two are the difference of two squares. So the outside and the inside will cancel each other out. You'll have a negative sign, a positive sign. Those cancel. You get the difference of two squares. All right, over cosine of x times 1 minus sine of x. Well, what's that right there? What's 1 minus sine squared? Cosine squared, right? So we can change that. Sine of x times cosine squared x minus cosine squared x all over cosine x times 1 minus sine x. Now we can't cancel out one of the cosines. You can't do that. So on top, we can factor out a cosine squared. And that leaves sine of x minus 1 over cosine x times 1 minus sine x. Awesome. Now that it's multiplication, we can start canceling a lot of things. First of all, one of the cosines cancel. These two cancel each other out, but they leave behind a negative 1. So the answer is negative cosine of x. They cancel, but they're opposites of each other. Sine minus 1 and 1 minus sine, almost the same. They cancel to leave a negative 1. So I hope you think that this is a lot more simple than that thing right there, but they have equivalent values. If you plug a value in for x, you get the same value. Just one's more simple than the other. All right, let's keep rolling along. Rewrite as an expression that does not involve a fraction. So we have common denominator, change everything to sines and cosines, and we have this where you multiply by the conjugate. So we have 1 times 1 minus cosine of x over 1 plus cosine of x times 1 minus cosine of x. This is always a choice to do. You can always just multiply by the conjugate and see where it leads you. Where does it take you? Does it get to something that I can change and not have fractions or not? All right, the top becomes 1 minus cosine of x, and the bottom becomes 1 minus cosine squared x. Difference of two squares in the denominator. You're thinking, well, how am I going to change that to not being a fraction? Well, let's just keep going with it. 1 minus cosine of x over, this becomes sine squared x. 1 minus cosine squared, same as sine squared. Oh, by the way, on a side note, 1 minus sine does not equal cosine. It has to be squareds. It can't, if it's just power of 1, that statement's not true. So if you see a 1 minus cosine, that is not sine. Can't do that. It's got to be squared. It's Pythagorean identities, they have to be squared. All right, so now, how are we going to write this without fractions? Now I use what I call, I don't think a book would call it, I use it reverse common denominator. Instead of combining, how about we split it up? Minus cosine x over sine squared x. Reverse common denominator. Take them apart instead of putting them together. 1 over sine squared is cosecant squared. So I got rid of one thing that was a fraction. Now I got to try to get rid of cosine over sine squared. That's minus cosine over sine times 1 over sine. That's still cosine over sine squared. That hasn't changed much. That's still the same thing. But now I can finally write all of this without any fractions at all. Because cosine over sine is cotangent, and 1 over sine is cosecant. There, I wrote that same thing. Now, it doesn't say simplify. It doesn't say, now, I don't know which one's more simple, but that's not the instructions. It says, write this without a fraction. There we go. We got it. So a little different instructions. Any questions? That's 5-1. How about 5-2 now? The only difference between 5-1 and 5-2 is in 5-2, I know where I'm headed. On 5-1, if they say, simplify this thing, I really have no idea where I'm going. I know the process, and I can kind of recognize when I'm done, but I didn't know that was going to be tangent. I promise you, I did not know that was going to be tangent when I first did it. I did it first period, and I didn't know where we were going. These, in 5-2, I know exactly where I'm going. I'm going to take this complicated side, and I'm going to turn it into that simple side. That's what we're going to do. We have a Pythagorean identity. The Pythagorean identity says cotangent squared of x plus 1 is equal to cosecant squared x. Tangent and secant go together. Cotangent and cosecant go together. So now if I minus 1, I get cotangent squared x equals cosecant squared x minus 1. So my very first step on this, taking the left side, turning it into the right side, is that top becomes cotangent squared x over cosecant squared x. Pythagorean identity. Next possibility, I can't do common denominators. I only have one fraction. I don't have any conjugates up here anymore, so that's out of the question. So now how about we turn everything into sines and cosines? Cosine squared x over sine squared x. That is cotangent. And then we got this big fraction right here, right? Cosecant is 1 over sine squared x. If I multiply the top and the bottom by sine squared, those cancel, and I'm left with cosine squared x. I think that's exactly where we wanted to be. So I turn the left side into the right side. So they must be equal to each other. Any questions? If not, let's just keep rolling. These two sections just require lots of practice. It's like shooting a three-point shot. How do you get better at shooting three-point shots? You got to do a lot of them. Thousands of them, right? All right, what do we have here? So, what do you guys think? What would you do? This is the number one on the test. Do what? Turn them into fractions? You mean sines and cosines? Yeah, let's do that. Let's try sines and cosines. Hopefully you recognize the left side is a little more complicated than the right side. We always like to work with the more complicated side. So secant is 1 over cosine. Cotangent is cosine over sine. And then we have just minus 1, right? Well, these cancel out because it's multiplication. We have 1 over sine squared minus 1. But how about we undo the sines and cosines? Let's make that cosecant. And cosecant minus 1 is cotangent squared by one of those Pythagorean theorems. Cotangent squared plus 1 is equal to cosecant. Tangent squared plus 1 is equal to secant squared. So tangent and secant go together, cotangent and cosecant go together. Yeah, we did it. That's only about a 2-3-step problem. I'm not saying, these are difficult sections, but I'm not saying every problem is going to be just horribly tough. Just some are pretty straightforward. All right, next one. Verify this. Any ideas? They're already sines and cosines. What do you think? Common denominator. Let's do common denominator. Let's just see where that leads us. 1 minus sine of alpha on top and bottom. And this one is 1 plus sine of alpha on top and bottom. Let's distribute the cosine through. Cosine of alpha minus sine of alpha, cosine of alpha, plus cosine plus sine cosine. And that's all over the common denominator. 1 plus, actually, if I multiply the denominator out, It is. They are conjugates of each other. 1 minus sine squared alpha. It's the difference of two squares. And those are called conjugates. All right, now what do we have? Well, we have a negative sine cosine, a positive sine cosine. Those cancel. And cosine plus cosine is two of them. 2 cosine alpha. Oh, I start to see it develop. So I got that 2 in there. You start to see it develop. Hopefully now you recognize a little bit better that 1 minus sine squared is cosine squared. And then one of these cancel, and you get 2 over cosine of alpha. Well, what I'm headed for is 2 secant of alpha. So eventually you kind of want to look at this and go, all right, I've done 3 or 4 steps. Where am I going? And you can look back at the top and go, oh, I'm going to secant alpha. So that's 2 secant alpha because 1 over cosine is secant. And there we have it. We turn the left side into the right side. Two left. What do you think? Which side do you want to work with? Left side? What do you want to do to it? What's that now? It will, but how are we going to do that? Now, 1 minus cosine is not sine. Yeah, we got to multiply on the top and bottom. 1 plus cosine. We're going to use the conjugate. 1 plus cosine. The top becomes, let's see, let's leave it like the, no, let's multiply. Let's FOIL through. Sine plus sine cosine over, the bottom becomes 1 minus cosine squared alpha. Difference of 2 squares, when you FOIL them together, the positive and the minus, they'll cancel out. Then we have sine of alpha plus sine of alpha cosine of alpha over, now we have sine squared. Now I'm going to look where I'm headed. I'm headed for cosecant cotangent. That's where I want to go. In order to get 2 separate things now, we got to do reverse common denominator. Sine of alpha over sine squared alpha plus sine of alpha cosine of alpha over sine squared. So reverse common denominator, that's how I term it. Sine over sine squared is 1 over sine. And one of these sines cancel out. We're left with cosine over sine. And that turns into 1 over sine is cosecant, and cosine over sine is cotangent. And I think that's exactly what we wanted. Yep, cosecant plus cotangent. Now, if you ended up with cotangent plus cosecant, that's the same thing. Any questions? Reverse common denominator. Common denominator. Turn everything to sines and cosines. Conjugates. Those are the techniques you have to use. Now, this last one, I suppose there's a long way to do it and a short way to do it. Now, I'm going to show you the short way to do it. Let's work with both sides. Secant squared x, I can factor out secant squared x. That leaves secant squared x minus 1. And on this one, I'm going to factor out a tangent squared. When I factor out a tangent squared, I get tangent squared x plus 1. Secant squared minus 1 is tangent squared. Tangent and secant go together, but it's tangent squared plus 1 equals secant squared. Tangent, secant go together. So if I have secant squared minus 1, that's tangent squared. And over here, I have tangent squared plus 1. That's secant squared. And I turn both sides into the exact same thing. So it must be true. They must equal each other. So on that one, I chose to work with both sides. This is the one you'll probably use the least often. But it does come up. Any questions? hopefully recognizing some of that stuff just became, I hope, a little bit easier.